Assalamu alaikum, dear students. Today in this class, we are going to start a new chapter, that's limits and derivatives. As you are well aware about the concept of relations and functions from your previous chapters. So in this lecture, we will be discussing the concept of the limit first. So regarding the concept of the limits, you should be well aware about functions, and you know what is domain and what's codomain and what's range. Uh, so if you know all these concepts, we will go to highlight the definition of the limit of a function. So limit of, for example, we have in the domain that x tends to a particular value a, and f of x tends accordingly to a value L, then this L is said to be the limit of the function f of x, which is symbolically written as limiting value x tends to a, f of x is equal to L. Okay, so this is actually limiting value of the given function in the codomain or in the range set. Okay, so to evaluate or to calculate the limit of a function at a given point, we have two approaches in the two dimensions. So here in your mathematics class 11th, as per your syllabus, we have two approaches. That is, one approach is the left hand limit and other is the right hand limit. So this left hand limit is actually to approach the given value x is equal to a from the left of the a. So this is called as the left hand limit, and if we approach the x is equal to a from the right of the function, then this is called the right hand limit of f of x at a. If the left hand limit and right hand limit, this is very important, if the left hand limit and the right hand limit coincide, then we call the common value of the limit of f of x at x is equal to a, we call this as the limit of the f of x, and this is denoted by limiting value x tends to a f of x. So we have different examples here. You can see these examples. Let's highlight some, let's discuss some example here. Say, you can see here in this illustration number, let's go to illustration number 9. You can see here, it is, we want to find the limiting value x tends to 0 f of x, where f of x is equal to x minus 2, 0, and x plus 2. So for the left of the 0, it is defined as x minus 2. For the right of the 0, it is defined as x plus 2. And x is equal to 0, it is defined as f of x is equal to 0. So what to do? We want to approach 0. So we will approach it from the negative side and the positive side. If we want to approach it from the negative side, our function will be defined by x minus 2. And if we want to approach it from the right hand side, it will be defined by x plus 2. So for example, x is equal to, here we will take different values of the x. For example, x is equal to minus 0.1 and or minus 0.01, 0.001 dash and dash up to 0.1. From minus 0.1 to 0.1, we take some values and we will evaluate accordingly the function. So the value of the function at these points will be, you will see here, it is for example, it is f of x is, since it is the negative of on the negative side of the 0, on the left side of the 0, so it will be x is equal to minus 0.1, so it will be minus 2.1, and accordingly these values. But for the right hand side, for these values, last three values, the function will be evaluated for this x plus 2. Okay, so it is 2.001, 2.01, and 2.1. Okay, from the first three entries, you see that we have limiting value x tends to 0, negative is equal to minus 2. These values are actually very close to minus 2. But for the right hand side, you see from the last three entries, they are approximately equal to 2. So right hand limit is approximately equal to 2. So we say that these two values, left hand limit and right hand limit of the given function, they are two different values. So these do not coincide. So if they don't coincide, we say that the function is limit of the function does not exist. So here you can see it very well. Um, Since left and right hand side of 0 do not coincide, we say that the limit of the function at 0 does not exist. And its graph can be seen here in figure 13.6. This way we can calculate these limits of these step functions. There are some simple functions also. We can solve them. We'll see them on the in the exercise. Before that, we will go to the algebra of the limits. So in the algebra of the limits, you know, just like the addition of numbers, subtraction of numbers, multiplication of numbers, division of numbers. So we have similarly the same rules for these functions, but how they are defined, it's like this. For example, we have limit of function, limit of sum of two functions, that is sum of limit of two functions. We have difference of limit of two functions, that's equal to difference of limit of two functions. If we have product of limit of two functions, that's equal to product of limit of these two functions. If we have uh, limit of quotient, that's quotient of the limit. Okay, so one more is that limiting value, for example, for a scalar function. If a scalar function is multiplied to a given function, then how can it be evaluated? Note that limit does not make any change in the scalar, so it is scalar times the limit of the given function. It's okay. For the polynomial function, you can see it here. Yeah, it's like this. If we have polynomial function f of x is equal to this, where these are real, and n is not equal to 0 for some. Now we know that limiting value extends to a, x is equal to a. Then for different powers, we will use accordingly. First, we will use the addition law of the limit of functions, and we will calculate them accordingly. You will see it is actually nothing but x replaced by a, so it is f of a. Okay, so we have used here the sum rule, and similarly we can use the quotient rule for this, and for the next, and for example, we want to evaluate the limit of the function given in this part number. First, it is a polynomial. We will solve it by one, and we will give limit to this x cube and x square and 1 separately, and we'll evaluate this. So this way we can solve these functions, limit of functions. So it's very easy. It is not any hard task to do, but there are some complications. There are some functions where evaluation of limits seems to be slightly different. So for those functions, we will go in the next lecture. But prior to that, we will go to the exercise. And in the exercise, we will be solving the small and simple functions like, you see, question number 1, its limiting value is x tends to 3x plus 3. So if we will give the limit, it will be 3 plus 3, and here it will be pi minus 22 by 7, and here it will be pi r squared, that is pi into 1 square, that's pi, and here we can give the value 4. We can evaluate this, but what about this? Yes, we can solve it. It's minus 1, that's minus 2. There's no problem. But what about question number 6? It is x is equal to 0, and in the numerator it will be 0 plus 1 raised power 5. It will be 1 raised power 5, 1 raised power 5, 1 minus 1, that is 0, 0 by 0 form. So such a questions will be discussed in the next lecture. Till then, you go through these basics, and you see whether there is any confusion or any question regarding the fundamentals of these limits. You are welcome to ask these questions. Thank you for joining the class. Thank you once again.